Good morning, guys. Can you hear my voice?
Yes, sir. Good morning, sir.
Okay. Good morning. Why very less students are there?
Sir, there is another class, sir. Class चल रही है दूसरी.
Which class? Mathematics.
No, sir. Side से इलेक्ट्रॉनिक क्लास. सेमीकंडक्टर पढ़ा रहे हैं.
Then how come you are not there and join this class?
Sir, I am on the hold, sir. It is on the last, sir. So I come in that class.
Okay. So we'll wait for 2-3 minutes. So others of your friends can join. We'll start.
Yes, sir.
So your class strength is 92, right? All right. So we will start our class today. Um, so from previous classes, excuse me, we try to understand what is an operating system is. We just ran through a uh, brief overview of what is operating system, what are the jobs of operating system. We had a brief overview. In depth how the process is created, how CPU is scheduled. We are yet to study that. In depth we will study how the processor will handle all these details. So however, once we had a brief overview of data structures, we came to know that a kernel is an important part of operating system, which loads first into the RAM to make sure that operating system is running. Kernel has to be loaded, right? So kernel uses different data structures that we saw in the previous class. We have different data structures like linked list, arrays, stacks, queues, trees, graphs, and so on and so forth. So we'll discuss all of them, and those are the uh, data structures that you're going to implement in your lab for the rest of your semester in the assignments. So thought of taking this data structures and covering what are the different data structures that we need to aware. We'll take a look at it, and after finishing data structures, we'll get back to operating system concepts, like how a process works, how what are the various CPU scheduling algorithms, or how what is the right now operating system, which algorithm it is using. All these things we'll try to understand in detail. Okay, so let us now continue. For, Let us continue our journey to discuss what is data structures. Okay, you might have heard a little bit about data structures in your first year C programming, But forget everything. Let's try to keep an open mind. We'll try to understand from the scratch. Okay, we'll try to understand from basics what is data structures is. So we have data. Data is means set of values or set of values. You can say anything. It could be a singular or plural form. Both we refer data. Okay. For example, 29 is one data. 1811 2021 is a data. ISBN 8123 zeros and followed by another zero is a data. Pascal is a data. Dollar is a data. Okay, so all the above examples, some values are represented in different ways. Each value or collection of all such values termed as data. Okay, so data could be any value or a set of value. Okay, so that's how we define data. So having it could be anything. Okay, it could be any data, either it is text or number or numeric or any other symbol. It could be a group of strings, a group of a combination of anything. We can call that values or a set of values as a data. Okay, now we have information. There is a difference between data and information. Information says that the term information used for data with its attributes. So in other words, a meaningful data or a processed data is a information. Suppose when I say 29, it could be any value, but when I assign some property, some attribute to the data, I call that as an information. For example, when I say 29, if I say that is an age of person, that is an information. So from the data 29, I'm getting some information. This could be the age of person. Now this is the age of person. For example, 18/11/2021 could be any value, not necessarily a date, but I can just represent a values. But you can say that when I say it is a date, it will give some information that okay, today or last Wednesday is the last Thursday is the 18th. When is the Monday, right? Okay, Monday 18 is last Thursday. Okay, so that was the date. Likewise, when I say ISBN 812300, the value might be anything. The set of values or the values could be anything. But when I say that is this is a book number, it gives me information from this data, right? When I say Pascal, it could be a nickname of the person or in a programming language. So we can get some meaningful information from this data. When we get a meaningful data, then we call that as an information. Okay, so dollar could be a dollar sign, right? So information can be defined as meaningful data or a processed data. Okay, so there is a difference between data and information. Data could be set of values. Information is a processed data or a meaningful data. Then we will try to define, once we understand the difference between data and information, we'll try now to understand what is data type. Okay, so data type is a term which refers to the kind of data that may be appear in the computation. This we already studied in C programming, right? So when I say that each data will have some type, we will categorize the different kinds of data that we need to compute. Okay, so for example, when I say 34, it is a numeric integer type. When I say 18/11/2021, it is a date. Then ISBN 81, it's alpha. It has alphabets also. It has numeric also. We can say that's alphanumeric. Pascal is a string. It's a group of collection of characters. It's a string. Dollars is a graphic symbol or ASCII symbol. Like we can define your data type, which kind of data that we will use in computation. Okay, so this is when you categorize, this is the data type, what kind of data, then we call that as a data type. So we have two kinds of data types. One is built-in data type or abstract data type. With every programming language, when we use we define the set of data types which are called built-in data types. For example, when you take C, you studied in your first year programming C, so you have an integer data type, float data type, character data type, double data type. Enum is your own data type, right? So these are the various data types that are inbuilt, which are already defined when you study the C programming says that when you define your data, you should declare what kind of data it is, which are in the built-in time. When you're using when you are using Pascal language, then you're using then this kind of data, right? The integer data, real data, character. You have to use this data type in order to define your values. So Boolean is another data, whether 0 or 1 or true or false. So this is the data types that are inbuilt in Pascal programming language. But if you observe in your C programming, there is no data type for this kind of date. This is one slash ddmmyyyy date. For date, is there any data type in C programming?
No, sir.
So as programmers, we can define our own data type. We can define maybe based on the date or based on the numerics, based on and how the date works. Like every month will have 30 days or 31 days or 28 days. Some years, leap years will have 29 days. Total, you should calculate 365 days or 366 days. We will define our own data type, how a calendar works, how the date works, based on the logic which is not defined in the programming language. That we call that as a abstract data type. Okay, so the programmers, we define our data type, which we can call that as an abstract data type. It is also called as user defined data type. So we will define how a date works. When I say date, how it will work, we can define in our own we have to write set of instructions and logic to define our own data type. That could be possible. Okay, that's what we call that as an abstract data type. Is it clear up to this point, whatever I'm trying to communicate?
Yes, sir.
Yes, sir.
Okay, so if you have any doubts, please stop me. We'll discuss at that point. So now let us get into the concept of data structures. So manipulation of real life data or user data requires three tasks. Okay, the three tasks are: we need to store the data in a such a way that computer will understand it. Okay, the storage representation of users data. What I am storing, suppose I am storing a file, I'm storing a movie, or I'm storing a web page, I'm storing a document, I'm storing n number of files. But when I'm trying to access it, operating system will go to that. Operating system will provide me the graphical user interface, that where it is stored, I'll go and click that place. But the system, how my data is stored in the computer, a computer should understand. Okay, it is not a genie, right? That it will automatically understand. It is not like that. We have to define how we are storing the data, how we are accessing the data. So whenever we are using some data, some information, whatever we are using in our real life, how we are storing the data in a way that computer will understand, we need to be clear. Then once it is storing, then we need to also define how fast we can retrieve. Okay, so you can retrieve the data in a way that user will understand. So computer has storage, and when you're taking it back, it should make sense to the user that this is the actual data what I'm looking for. Okay, so retrieval of data, retrieval of stored data. Then the third operation is transformation of the user data, which means that various operations I could perform on the user data, it will be transformed from one form to other form. For example, I have two integers. I stored a value as for example, so I'll get 10,000 rupees every month salary. Then I want to calculate what is my annual income. Okay, what is my annual data? Then I have to calculate 10 into 12. The data will change now. Okay, the result what I'm expecting, the data will change. Then I will update what is the total income. Then if I want to calculate what are the expenditures, then minus something, then I'll take b value. That b should be like, say, every month I'm taking 8,000 rupees as expenditure, then I'm saving 2,000 rupees. What is the result amount? So when I'm storing some information like my income is 10,000, my expenditure is 8,000, A and B. What is the savings I have? When I want to do some operations on it, I will do addition or subtraction, multiplication, division. Then the data will again change. Okay, the data what I have, the balance will be keep on changing. When I'm trying to perform some operations on the user data, it will be transformed from one form to other form, right? So it is possible to transform one form to other form. So when we now integers can be transformed into real, or if I'm transforming from ASCII value to character to integer or integer to ASCII values, it could be possible. You can transform from one form to other form. So we are also need to take care of that. So when we discuss about data structure, how we are storing the data, how we are retrieving the data, and when we are applying some operations on the data, how it is transforming and how we are going to take care of that is a basic three things that we need to take care of it. Okay. So having said this, let us define what is a data structure is. So given for a given kind of user data, its structure implies three things. Okay. When I say structure, we have to define in three things. One is domain, function. So we have to define three things. One is domain, function, and axioms. So what is domain? Domain is the range of values that the data may have. You cannot have infinity values. You need to define your set of range, because computer cannot store infinity values, right? When you say your RAM is 2 GB, how much memory it can store, or maximum it can store?
2 GB.
Right. So in terms of bits, can you tell what is 2 GB in terms of bits? 2 to the power of 30. 1 KB is 2 to the power of 10. 1 megabyte is 1024 into 1024, that is 2 to the power of 10 into 2 to the power of 10 to the power of 20. 1 GB is again 1024 into 2 to the power of 20, that is 2 to the power of 10 into 2 to the power of 20 to the power of 30, that is 1 GB. 2 GB is 2 to the power of 31. So maximum those many bits only you can able to store. So those 2 to the power of 31 number of bits could be maximum. If you say that purely positive integers, then it could come approximately to 0 to maybe maximum 65,000, right? So it will come even more. 2 GB means even 2 to the power of 30 means it will come in millions up to 10 lakhs. Okay, you can't go beyond that number. If I give 1 crore, my computer will not understand for the 2 GB data. Okay, then we need to do some other operations to store that meaningful information. So you need to have a range of values. The point is you need to have a range of values that the data may have. You cannot have infinity values. So the domain is also now termed as sometimes data object. We can interlink, but don't get confused. Okay, so we need to define a domain. When we are defining the structure, we need to set the range from this range to this range. Then the function, what are the set of operations that we are legally applied on the elements of the data object or on the domain. So having this is the range. What are the operations that we are going to apply in that? Also we can define. Then the third is axioms, which are the set of rules with which the different operations belong to a function actually can be implemented. Okay, the set of rules like you cannot divide by 0 or you cannot have an infinity. All this some rules we will define. When you do addition, this will be the case. When you use logical and or logical or, this could be the result. We will define set of rules on that structure. Okay, on that function with different operations that belong, that could be actually implemented. So a structure implies these three following things: domain, function, and axioms. So having these three things, then only you will be able to imply what is the structure means. So a data structure is a triplet. So now we'll define a data structure. A data structure is a triplet with domain, function, and axioms, where D is the set of data object, F is a set of functions, and A is a set of rules to implement the functions. So a data structure is a triplet with DFE. For example, when I say that integer data type, int in C programming language, the structure includes of the following. So when I say domain, the range of values will be minus 32. When you say integer, it has 2 bytes. So 2 bytes maximum you will get 2 to the power of 2 bytes, right? Or 4 bytes. So nowadays it's 4 bytes. So it is 4 bytes are 32, 2 to the power of 32 number of bits you can store. Okay, so minus it can go to minus 2 to the power of 16 to the power of 16, right? So those many bits you can able to store in these values. So what are the operations you are applying on the integer data type? You can apply addition, subtraction, multiplication, division, and modulus. These are the set of operations that we learned in our C programming language. And what are the rules? Binary arithmetic operation to perform addition, subtraction, division, multiplication, and modulo operations. So binary operation we are doing on this values with these operations. How the addition works, how the multiplication works, we will define that addition is plus, subtraction is minus, and these are the rules that we will define on the exams. This is one example how a C programming looks the structure of an integer data type. Okay, so a data structure is a set of procedures to define, store, access, and manipulate data. We can define a data structure as how we are storing, how we are defining the procedure to store, access, and manipulate the data, or you can say that the organized collection of data is called as a data structure, or it is a logical only. Okay, the logical or mathematical model of a particular organization of data is called data structure. These are the various definitions, but more or less it gives the same meaning. Okay, so the logically, for example, when I say that there is a stack, there is a queue, there is a tree, so it is not a literally tree. Okay, the logical way, the logically we are arranging the data in a way that we will make sure that how the data is stored and computer will understand it, so that we will try to see how fast we can get the data if we are following a certain logic. Okay, so it's a logical way or a mathematical way, a model we are using to particularly organize our data. Okay, so when I say the tree, there is a root, there is a left child, there is a right child, we have branches. That is a logical representation how we are storing the data. Okay, so when I say linked list, you the data which having a header, the next data will be linked to its address. That's how you are making one data after another data. You are keep linking to each other, and you are storing in an array. You define your array. You are storing sequentially one after the another. You are defining how you are storing your data in a logical way or a mathematical way, so that how we are organizing the data defines your data structure. And there are various ways you can make that logic. There are various mathematical ways, there are various logical ways. That's how we have different data structures. So you can say the data structures is not one way. Briefly, it is categorized into two types. One is linear data structure and a non-linear data structure. So in linear data structures, we have arrays, strings, queues, stacks. Stacks will also part of that. This is not strings, this should be stacks. Okay, I will change this. Okay, and a linked list. So these are linear because the data will store in one sequence, one after another. Okay, so when I say array, your the first element will be stored at 0th position, the second element will be stored after that, the third element will be stored after that. So there is a sequence. Okay, you are following a linear model, a single dimensional array, or when you are following a stack. So this is a stack. I will update this. So stack or strings you can store in a linear way. This for strings also you need to use arrays. So for stack also you are keeping one after another, one after another, one after another on the top. So you are following a linear model. Okay, when you are making a queue, you are making a queue standing in the line, one behind the other, one behind the other, one behind the other, right? So it is also a linear way of arranging the data. If you are arranging that the logical way, and linked list also one after another. The next data will be stored in the next data address is stored in the previous node. So you are making a logical way of linking one data to another. But whereas trees, graphs, table sets, they are very different. If you see a graph, the Google map, if you observe, so one source to destination, and you can go to another destination, you can follow different set of places is one way of visualizing the graph, which is not a linear, which will not store in sequential. So you can go from one place to other place, or if you have a tree, you have different branches. Don't worry, I will show a graphical representation also how what are the various data structures will look like. But this is a brief idea, like you are storing tables, you are storing sets. These are all non-linear data structure. So you will not form a linear way of accessing or storing the data. So these are the various data structures that we are going to look at it. At least we'll try to cover as much as the fundamentals that we need. So once again, you can see this is the last, which is an important make logical understanding. The logical or a mathematical model of a particular organization of data is called a data structure. Also, it is a set of procedures to define, store, access, and manipulate data. In simple words, layman words, if I have to tell, this is a data structure. But if I have defined very properly, then this is the proper definition. Data structure is a triplet with domain, function, and axioms, where D is the set of objects, F is the set of functions, and A is the set of the rules implement the functions. So this is how we define the data structures. Does it make sense?
Yes, sir.
Okay, so unless you don't ask questions, I'll assume that you are understanding what I'm trying to say. If you are not raising questions, I'll assume that you understood everything. Okay, so if you don't understand, please stop and ask. We can discuss that. I will explain it again. Okay.
सर थोड़ा धीरे चलिए, लाइक बहुत स्पीड हो जा रहा है, कैप्चर करने में थोड़ा प्रॉब्लम आ रहा है.
Okay, so we'll go slow. So up to this is okay. You want me to repeat any point?
Now it's okay, sir.
All right. So having understood a brief definition of data structures, now let us try to understand what is an algorithm. How we are going to implement data structures? The best way to implement data structures is through algorithms. So now let us define what is an algorithm and what are the various ways we can define an algorithm, and how we are going to calculate which algorithm is efficient, which algorithm is good. Also, we will try to understand that. So an algorithm is a specifies that it's a procedure for solving a problem in finite number of steps. Okay, so this is finite is very important, because when you are when there is a problem and you want to solve that problem, you need to define the solution in only finite number of steps, because you cannot say that it will be solved in infinity number of steps. That is not an algorithm. Okay, you cannot define your algorithm in infinity number of steps. So whenever there is a problem and whenever you are trying to find a solution, and that solution, how we are doing it is an algorithm. Okay, so there are various ways to that. We will try to look at it, but in simple words, an algorithm specifies a procedure how to solve a problem in finite number of steps. A computer scientist, Nicholas Ward, says that when I say program, a program, when you have written C programming in your first year, it follows some steps. Okay, some logic behind that. Okay, when I want to calculate what is a factorial of a number, there is a logic, right? You have to when I say n 5, suppose n is equal to 5, the logic you are trying to follow is 5 into 4 into 3 into 2 into 1, right? So there is a logic. How we are finding a factorial of a number, you are multiplying one after another till when you reach to 1 is the steps. You are defining the procedure how to solve that problem. Okay, so that is one algorithm, and you are defining in set of instructions with the available data type or with the instruction set defined by the C. But the logic how we are developing, like when I say n, you can start either 5 into 4 into 3 into 1, or you can start from 1 into 2 into 3 into 4 into 5. Either way, you start from 1 to 5 or 5 to 1. You can do either way. Either you are using increment or decrement. a simple way of defining your algorithm or set of procedures is algorithm, and you have data. So 5 is one data I'm giving. The 5 factorial answer will give me 120, but when I change the data, my result data will also change. When I say 4 factorial, then my result will be 24, right? 4 into 3 into 2 into 1. So you have to give some data to your algorithm to get the result. So a program is a algorithm plus data in just simple words that we already learned in your first year. But however, we will try to keep learning that, because that is not going to stop. So an algorithm is an effective procedure for solving a problem in a finite number of steps. That is what we define here. So algorithm is a well-defined list of steps for solving a particular problem. These are the same words, but I'm keep repeating that there is a problem, a particular problem, and we are going to define a list of steps for solving it. An effective procedure for solving a problem in a finite number of steps, or a specified procedure for solving a problem in finite number of steps. These both are all same meaning. So this is a simple algorithm. When I say algorithm, there is a problem and you want to find a solution in finite number of steps. Okay, so that's how we define algorithm. But in computer language, we'll define a program is equal to algorithm plus data. Okay, so that's how we'll try to understand that. So there are different ways of stating algorithm. One way is like step form. Okay, step form, in step you will write step 1, step 2, step 3. They are a simple procedure for solving a problem written in steps. Okay, written in statements. So each statement solves a part of the problem, and this together all the steps completes the solution. Okay, the step form is just a normal language that we define a procedure. Every statement that we define some action which is logically related to the preceding statement. For example, I want to make a pot of tea. Okay, I want to make a tea. That is my problem. Now how I'll define the steps. Step 1, this could be numerics. Let me change this. Okay, so step 1, I'll make the if the kettle does not contain water, I'll fill the kettle first with water. Step 2, plug the kettle into power point, I'll switch it on. Step 3, if the teapot is not empty, then empty the teapot. Then 4, place the tea leaves in the pot. 5, if the water in the kettle is not boiling, then go to step 5. So till the water boils, you keep doing that. You stay in the step 5 only. Then step 6, switch off the kettle. Step 7, pour water from the kettle into the teapot. Right. So these are the various steps that we follow to make a tea. Is it correct?
Yes, sir.
So when you are writing, and this is also a problem. How we are making, I mean, like you can define any problem, and how we are doing the solution. You are writing step 1, step 2, step 3 in terms of logically. You are defining in written language in a statement. That is one way of stating the algorithm. And you can write in normal language, and each step is a part of the problem, but the all steps will give you the complete solution. Okay, so this is one way. This is one way of doing this step form. The second is very familiar. Maybe you would have studied in your first year C. It's called flowchart. You can define your algorithm in terms of flowchart. Flowchart uses some symbol, some language. It uses combination of symbols and language to represent the sequence, decisions, repetition actions, and so on and so forth. For example, I want to find first 50 natural numbers. So I will define a flow chart like this. So the start will be like this, like the start and stop will be ellipse. You'll define in terms of an ellipse. You'll define the steps in terms of a square box. So sum is equal to 0, you'll define n is equal to 0. Then your operations you are defining, n will be n plus 1. you are incrementing every time the value of n. Then you are adding sum, because sum and n values are 0 initially. Now when you increment, n value will become 1. Some value is 0 here, so n value will be added into some value, and until n reach 50. If n is 50, then only we'll break the loop. We are checking the condition. All the conditions will be in a rhombus. Okay, we will have a branching. So if n is not 50, then again we'll go to n value, will increment, we'll add that value to sum, and again now n will become 2. We'll checking to where 2 is equal to 50. No, then again it will go n is equal to 3. Then it will again add. Now some value will be 1 plus 2 plus 3. That would be each iteration you will keep adding the value. So until you keep running this loop up to 50 times. So when n value will become 50, this condition will hold true. If it is yes, then the value in the sum will print. This is the output. Input output we will keep in parallelogram, and we will stop. So the arrow and the ellipse, a square box, a rhombus box, or a parallelogram will help us to define the set of steps or a procedure how to solve the problem. Okay, so we are defining in terms of a flow chart. So you can state your algorithm in terms of a flow chart. Perhaps some of you would have designed, when you are trying to find the solution, a flow chart, how the data is flowing, what are the conditions we need to make, what are the decisions we need to make, how the loop is running, where we have to make decisions. Everything we can define in terms of flow chart also. This is also one way of stating my algorithm. Right? Is it make sense?
Yes, sir.
Have you studied flowchart in your first year?
Yes, sir. We study, sir.
Right. So this is one way of defining your set of procedures to solve a particular problem in finite number of steps. You have only finite number of steps, right? So this is one way. Then the third way is a pseudocode. In pseudocode, we will write is also one way of representation of algorithm. It differs from the step form and also way of using some symbols. Okay, so it restricts its vocabulary. We will have only few vocabularies to define its action for a solving problem. For example, we will say start. We will write if, then, print, stop. So we will use vocabulary, English words, but in a restricted way. So one problem with the human language, it seems to imprecise. I mean, it's not perfect, but a pseudocode in human language will have more precision. Will try to more accurately, will try to define with the limited vocabulary. So for example, when I want to find a maximum of 3 numbers, I'll write step 1 start, step 2 print enter 3 numbers, step 3 input ABC. Then I will initially assume that maximum value is A. I'll compare B with maximum, which is A. If it is condition is true, then B is greater than A, so B will be stored in max. Then again I will check the C is greater than B. Then if this condition is true, then C will become max, right? So if either value, one of this values condition fails, then the appropriate maximum value will print, right? This logic will work. So if A is greater, then maximum value is A, then B, this condition will fail, this condition will also fail. If A is bigger, then it will print A. If B is bigger, then this condition will be true, this condition will be false. So then print B. If C is bigger, then this condition you store, this condition will fail, this condition will also fail. So you will print C value. So all conditions are working. So we are defining only in minimum number of steps with minimum vocabulary with minimum symbols. So A will be, the left arrow says that A is stored in maximum value. You are comparing here and you are printing, you are defining these are the inputs, this is the print value which you are printing on the output. So you are defining in a simple minimum number of restricted vocabularies to define your algorithm in a more precise way. Precise means a more accurate way. Okay, this is a pseudocode. So the most recommended way of defining your algorithms are pseudocode. So in the most of the classes that we're going to study in the coming future, we are going to see all our algorithms in terms of pseudocode, or any textbook, any standard textbook in data structures or algorithms you take, you will find a pseudocode. Okay, you take algorithms core man book, you take cryptography by Forozon, you take data structures by Samantha, you will find all the algorithm, how the logic will work in terms of steps, in terms of pseudocode. Okay, so how we are defining pseudocode is we will come to how we are stating the way of algorithm. I will define the pseudocode, how we are going to write. So in order to express an algorithm for a given operation, we will assume different control structures and notations. So when I'm defining an algorithm, we will follow this notation. Most of in our classes, we are going to define algorithm in a set of steps like this. So this, I will say, this is the algorithm. What are the name of operation that I am going to define, what are the input parameters, what are the output parameters. So this is the input, specification of the input data for the operation. This is the output. I'm going to write what is the specification of output after the successful performance of the operation. I'll define what is the data structure if the operation assumes other data structures for its implementation. Then I'm going to define steps. Step 1, this is going to happen in terms of simple code like input ABC. Those are my input values. And right, I'll condition, if this condition is true, then this is going to execute step 1 inside step 1 2, right? If this condition will fail, else will execute 1 2. Then if we'll close here, then again some set of statements I'll define, set of steps I'll define. Then I can write while condition do, if the condition is true, then do this. If after this condition fails, you stop end while, then you follow some set of other statements and you will stop. So this is how we will define an algorithm in the subsequent class, which is a standard way you will find in any textbook, that how an algorithm is defined. Is this okay?
Yes, sir.
Yes, sir.
We'll discuss time complexity in the next class, because once we start discussing, we'll be not able to finish that. It will take a lot of time. So we will discuss time complexity on Thursday's class. So this is how we'll define a data structure and algorithms. If you have any doubts up to this point, you please ask. I will repeat it. Okay.
Excuse me, sir.
Yes.
Hello. Sir,
Yes. Yes.
are the notations of pseudocode fixed, or it's just it's to make it understandable?
It's make to understandable.
Sir, they are not fixed.
Fixed means you have to define what is your input. You have to define what are the, you have to define what is your algorithm. What is the name of operation? What are the input parameters, output parameters? This all we will define.
Okay. Okay. Yes. Thank you, sir.
This is all we have to define. These are the steps we are going to do that. For example, I'll show you if any algorithms you have. This will take a lot of time. That's why. This is one way of pseudocode. Okay, insertion sort. When I say, we will discuss in next class how this insertion sort will work. So you are defining for loop here 2 to length of a. So a is your input, and a of j will be stored in key. Then whenever you say double slash, it's a comment. In C programming, that's how we understand. Whenever double slash is there, this is a comment. Instead of a into stored j, then the step 4 is I is equal to j minus 1. This is a simple way of pseudocode. How you are defining? You are defining while, and these two conditions should satisfy. This is a logical and. So you're defining this step. You're storing. This is an array. So this is one way of using your pseudocode. It's for our understanding. it's not strictly we are writing any programming language. I'm not declaring J as an int, key is an int, what is my array size. I'm not worried about that. All I'm worried about is that I need the minimum variables, I need an array. So I'm trying to manipulate with my data like this only. So when I say merge sort, I'm using here recursion. So merge sort, I'll pass 3 inputs. So I'm dividing my values into 2 halves. Then again, I'm calling the first half, then second half, then I'm merging it. So this is a simple way. Then how merge will work? We are again defining the set of steps. This is a pseudocode. I'm not following any logic, but I'm writing my way of solving the algorithm in some set of steps.
Yes,
Okay.
sir. That was what I was asking. Like we use double slash to comment and see. Like someone wants to use a hash. Can we do that? Like it is it set in stone or is it flexible in that sense?
Yeah, in pseudocode, it's recommended to use double slash.
Okay, thank you, sir.
So there are few things we will try to keep in our basics. So usually we will follow double slash, and you will, whenever you are writing for loop, we will keep one tab space. We will not follow the same line. You see this for loop here, we are using one tab space for the next elements. So this will come here. Then while loop, again we are keeping one tab space to follow. These are the steps. So this step is outside of while. Because of tab space, it came out of the while. Okay. So that's how we will try to understand. This while is inside this for. So when you are writing or implementing this pseudocode in C programming or Java programming, you should write this while inside this for, right? You will put flower, you will open the flower parenthesis here. You will not close here. You will open one more. You will close for this while loop here. You will close for while loop here somewhere, right? But we are not strictly pinpointing to one language. We are not saying that this is C programming, this is Java programming. We are not doing that. We're defining the set of steps in a pseudocode. That this is also a code, but a pseudo means it represents a programming language which is not actually a coding language, but a pseudo form. Okay, it's not exactly a coding language, but that's why we call that as a pseudocode. Okay, so we'll define our algorithms in terms of pseudocode most of the times. Every time, now and then, whenever I'm saying data structure algorithms, you will see what are the input, what are the output, what is the data structure, what are the things, the steps that we're going to are part of that operation that we're going to carry out. I will make sure that this all things are there. Okay, but now and then some examples when I'm taking from other textbooks, they may define in little different way, but for humans we can easily understand that will be not making much difference. Is it clear?
Yes, sir.
All right, so I will stop here. I will let me upload the PPT in your Teams. You can verify whether you'll be able to see the PPT or not. So time complexity I will discuss in Thursday class, because if you start discussing, it will not finish now. So, but I will discuss in depth. We will understand why the time complexity is important, and these are all part of your curriculum that they asked it. So we will try to do that. Give me 1 second. Let me upload the slide. Meanwhile, if you have any doubts or anything you want to discuss, you please do that. Okay. I'm trying to teach from basics, making assumption that you don't know anything. So I'm not assuming anything that you no need to have any background knowledge. So I hope what I'm trying to say is making sense to you. If you are not able to understand, you can please again ask me to repeat. I will repeat it without hesitation. Okay. So uploaded the PPT in your team. Can you verify lecture 5, Introduction to Data Structures Part 1?
Yes, sir.
Okay, so go through the slides. If you have any doubts still, you can ask me on Thursday's class. So if no questions are there, we will stop the class now. We will resume from Thursday. You can come on Thursday.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.